Hello, my name is Aditya, and here is my walkthrough of the Face Authentication API that I have created for this assignment. First, we will look through the system architecture and then controllers and the face recognition module. After that, we will look at the Postman demo of registers authentication and false positives and negatives. And after that, I will keep why the false results occur and how to improve the system. So let's dive in. So here is my architecture of the project that I have created. Postman is acting as a client here. It will end a server which is created in Node.js with two endpoints /register and /authenticate. So the server basically does, it uses multer to first extract the image buffer into our RAM and then uses the face module API to detect whether it has face or not. And if it has face, then it converts it into landmarks, and then these landmarks are converted into 128 dimensional vector, which is then again taken by Prisma, and raw using raw queries we can directly seed this into the PostgreSQL database with PG vector extension. We are using PG vector extension, that's why we have to use raw queries here, because PG vector is currently not supported, has a type which is not supported, which is vector type, which we are using for embedding and storing it in the PostgreSQL database. Now let's look at the code. The code is divided into mainly three files. First, index.js, it is just handling the multer which takes the image, and it limits also the image to 5 MB at max, and it acts as a router here which goes to two handlers, register and authenticate. First, it will start the server, but it will first load the models so that and await for it, so that the models are first loaded before any image is taken from the user. After that, let's look at the face recognition API. We are using large Mendic face API, which has been pretty much upgraded face API with better ESM support and Node.js compatibility, and that's why we are using, and Bun is also supported with this, that's why we are also using it. So we have to monkey patch this using canvas because it will not work otherwise, due to because it is only for browser. In this module, we first load the models and then the face recognition happens here. It detects it through canvas we load the image buffer, and it detects the face then afterwards, and if the detection is fail, it will return null, otherwise it will return a 128 bit floating 32 array like buffer. Now let's look at the controllers. It has two controllers, first register, second authenticate. Here the threshold is also defined. So there is one thing I like to add, how the extraction and the matching happens. Extraction, first it will take the image and convert it into landmarks, and then convert that into vector, and then we store it in the database. That's how the extraction happens. But how the comparison happens, it takes the vector that is provided during authentication, it takes the image and converts it into a vector, and then this vector is compared inside the PostgreSQL database using Euclidean distance, and which distance we specify in our project should not be greater than 0.42, otherwise the face will not match. we have shifted the matching to the database for better efficiency. Otherwise it will fill up the RAM also. So now let's look at the controller. We have two controllers, register and authenticate. Register just takes name, email and file, multi-part form data, checks whether they all exist or not, checks if exist already or not, and after that it extracts face descriptor. And if the face is not detected, it will return 400 and could not detect a face in the provided photo. Now let's look at the descriptor. It will convert it into one descriptor string and then store it as a vector in the PostgreSQL data. After that, the user is registered successful. Now let's look at the authenticate API, authenticate handler. It will expect us to provide email and the multi-part form data file. If email is not there, it will just return success false. Now if both of them exist, it extracts the descriptor. If it again cannot find the face, it will tell could not find the face, and after that it is converted into a string, and then this vector is compared against a user photo whose email is this provided in the authentication, and they are checked whether they both matching or not. Otherwise it will return face 404 user not found if the match length is 0. And if these conditions are true, means the distance is less than the match threshold, then identity is verified. Otherwise it will return 401 unauthorized, means the user has provided the wrong image. Now let's look at the database. It is a lightweight database with ID, name, email and face descriptor, which is a vector 128 dimensional. Now let's look at the Postman demo. I have already ran it once, so I don't think it will work again. Now let's convert this into user A. I have just changed this email. Now let's send again. So user A, now we have a slightly different email, user capital A. Now it is registered successfully, means the image I have used here is this. This is a clear image of mine which I have used for registering. And after that we will authenticate. Since I have changed my email, so change it here also. Now send it again. Identity is verified, user capital A @gmail.com with a distance of 0.36, which is slightly less than our threshold. So it has verified our identity. And now let's register another user with a different face, which is this. This is an AI generated image, and by the way, I have used this image to authenticate, which is completely different from my registering image, which is this. Now we are using this image for registering another user. Now we are sending the request and it has successfully registered the user. Now let's look at the spoofing part, where I send user B registered image and my email ID. Let's see what happens. It clearly says 0.87 distance face does not match the provided email. So it prevents a spoofing here. Now let's take a non-face image, which is this logo I have used. So non-face image could not, now let's send it, could not detect a face provided in the photo. Now let's see a false positive. Here I have sent a false negative. False negative image means that I have given a photo which is blurry, and then we are checking whether it matches or not. I will send the data and it will return this because our threshold is 0.42. It is slightly above that. So this is fine. Now let's talk about the false negatives that I have encountered. False negatives generally occur due to lighting issues and distortions in the image, blurriness in the image. And false positives are those images where a person just looking like me tries to authenticate and he gets authenticated. In this, and that mainly happen due to threshold issues, which if I set it really low, it will not match my face even, and if I set it really high, it will match all my siblings' faces also. So how can I improve this project? I can improve this project by adding a liveness detection check to it. Users have to blink so in order to get registered. So after that, we can check whether the user is live or not. And we can also have a better embedding by making users to upload 4 to 5 images of themselves, so that we can get a clear embedding vector after that. And that's it. That was my project. That's it. Looking for feedback. Thank you.